Alright, today's lesson is over surface area. So we're going to start by talking about surface area of prisms and cylinders, and we will pick up the other shapes in the next chapter, I believe. So what surface area is, it is the sum of the area of the faces of a solid. So kind of a tangible way to think about this, if you're wrapping a present, it's how much wrapping paper you would need, or if you're building a house. So how much wood would you need for the outside walls? So the area of all of the sides, okay? Now, something that can be really helpful is by looking at a net of a solid. So a net is a two-dimensional representation of a solid. So it basically means that if you have a box and you want to find the surface area, if you actually had the physical box and you could take apart the sides and lay it flat, that's what its net would look like. And sometimes it's really helpful to look at the nets when we're developing these formulas. So, okay, so the first one we're going to look at is how to find the surface area of a prism, and we call surface area S. So whenever we talking about area, we use A, volume V, so surface area is going to be S. To find the surface area of a prism, we are going to take the sum of twice the base area and the product of the base perimeter and the height. So if we look at this formula, I find it helpful to break it down into pieces. So that big B is what we are going to use for base area. And that'll be pretty consistent throughout the rest of this chapter. Anytime you see a big B, we're going to be talking about base area. Anytime we see a P, same thing except base perimeter. Height is going to be the height of the prism. Okay, so that's going to stay fairly consistent throughout the chapter, so very good to kind of keep those in mind. So let's look at an example. So let's say we have a rectangular prism. We're really going to test out your drawing skills this chapter. Okay, so we've got this rectangular prism. It is 14 feet wide, 4 feet long, and looks like it is 3 feet tall. So I want to find the surface area. If this was a box, I want to know how much wrapping paper would it take to wrap this. So what I like to do is I like to find each of these individual pieces. So I know I need to find the base area, and I know I need to find the perimeter, the base perimeter. So we're going to use that base as the surface that it's sitting on. So it's going to be that 14-foot by 4-foot base. So if we start with finding the base, the area of the base, to find the area of a rectangle, hopefully you recognize that we're going to take 14 times 4, so the area of my base is 56 feet squared. Okay, then we need to find the perimeter of my base, so we're going to take 14 plus 14 plus 4 plus 4, and when you do that, you should get 44 feet. Once we have those pieces of information, we can go ahead and plug them right into my formula. So we're going to take twice my base area, which we found to be 56, and we're going to add my perimeter times the height of my prism. Now, since it's sitting on my base, I can just think how tall would it be, and you can tell pretty easily from that picture that it would be 3 feet tall. When you punch that into your calculator, you get the surface area to be 184 inches squared. So rectangular prisms, not too bad. If we look at, this is called a triangular prism. Okay, so this triangular prism, make sure you're labeling the dimensions the same as I am. We know that dimension is 6 inches, this dimension as 8 inches, and it's going to be 12 inches that way. Okay, now this time, the first thing that you really need to do is kind of decide which ones your bases are. Now, with a prism, it can be kind of tricky because it's kind of tempting to say that that rectangle on the bottom is your base. But when we're talking about prisms, the bases have to run parallel to each other. And if you look at that rectangle on the bottom, there is no side on that prism that runs parallel to that bottom rectangle. And if you keep looking at your shape, hopefully you recognize that the only sides that are going to run parallel to each other are those two triangles on either end. Okay, so we are going to use those triangles as our bases. So we first need to find the area of these triangles here. Okay, so remember the area of a triangle is found by half the base times the height. So now we're talking about the base of my triangle, which is 8, and the height of my triangle is 6. So when you get that worked out, you should get the base area of 24 inches squared. All right, well now we need to find the perimeter of my base. So to find the perimeter base, I'm sorry, I forgot to give you one dimension. We're going to say that long side over on the other side is 10 inches. So for the perimeter of my base, I have 3 sides that I need to add together. I need to add that 6 inches, the 8 inches, and it doesn't tell me what that diagonal across from the right angle is, but if you look on the other side of your prism, the one that I forgot to give you in the first place, I know that that last side is 10 inches. So the perimeter of my base is 24. Okay, so now if we plug those into my formula, we are going to take twice the base area plus my perimeter times the height. Now remember, this height is the height of your prism, and the reason this can get a little tricky is because it's not sitting on my bases, so you kind of have to use your imagination a little bit, and it's sitting on one of its sides. So if you tilt that prism up so it's actually sitting on that triangle, think to yourself, well, how tall would it be? And hopefully you can recognize that it would be 12 inches tall, so we're going to use that as my height. So when you plug all those in, you end up with 24 feet squared for your surface area. Okay, so we can also find the surface area of a cylinder using basically the same formula, except with circles it just gets a little more complicated because we have pies and radiuses and squares and all that. So we're still going to take twice the base plus the perimeter times the height, but remember, we don't usually talk about perimeter of a circle. Instead, we call it the circumference of a circle. So we could use this formula here, but it's usually a lot more meaningful to actually go ahead and substitute in the area of a circle and the circumference of a circle. So let's jump into an example. So I have this cylinder here. Looks like it has a diameter of 3 inches. And it is 5 inches tall. Okay, I'm really hoping that the first thing that you notice is that I'm given my diameter, and we learned in the last section that we really would rather have the radius. So if my diameter is 3 inches, my radius is half of that, so my radius is 1.5 inches. Now when you're finding surface area of a cylinder, instead of finding the pieces, you can really just plug it all into the one formula because we already have everything we need to know. So to find the surface area of a cylinder, we're just going to use that formula there and plug in the things that we know. We're going to take 2 instead of pi, plug in 3.14. We just found that my radius is 1.5, and we're going to square it, and then I apologize, but I have to go on a separate line. And then plus 2 times my radius times my height. So I just simply took that formula and I plugged in the numbers that were on my cylinder. So when you punch all of that into your calculator, you should end up with 61 23/100 inches squared. So the surface area of a cylinder, there's kind of a lot more to it, but it's really just plugging some numbers into a formula. So I want you guys to try this last one by yourself. So this time, we're given that this dimension is 6 inches, this dimension here is 10 inches. So recognize what dimensions you're given, plug them into your formula, pause the video, see what you get. Alright, and hopefully you got 602 and 88/100 inches squared.